Okay, sorry, I'm back. Alright, so this problem here, there are 80 dogs and cats in the animal shelter. The ratio of of dogs to cats is 5 to 11. How many of the animals are dogs? Okay, so this is kind of going to the next step here. Now, I already talked about this here. The order of the words here dictate what the numbers mean. So since dogs comes first, the 5 is the dogs, and the cats is the 11. Okay? And the 80 again is all of the dogs and cats all together in this particular animal shelter. Now then, let's take a look at this. Alright? This is putting a ratio of dogs to cats. But what we need is how many dogs are there all together. Okay? So if we just look at these numbers right here, all together, how many animals are there? Well, all together, there's 5 dogs and 11 cats. So 5 plus 11 is 16. So we can make a rate of dogs. All right, let's look at this. A rate of dogs to be 5 dogs for every 16 animals. Okay? So 11 plus 5 is 16. So this 16 is the 5 dogs plus the 11 cats. Okay? There's 2 ways of doing this. If I stick with what I've been already teaching you, I could just divide this and come up with a unit rate. All right? It's going to be a weird number, but you could do that. So if you just divide 5 by 16, go ahead and do that in a calculator because it's going to be a really kind of crazy decimal. All right? That's going to be 0.3125. Okay? So what this means is there is 0.3125 dogs for every 1 animal. Okay, now that's a ridiculous rate. Obviously, that's not a real rate. But this is one way of doing the math. Okay? And it's consistent with what I just taught you a while ago with the candy bars. Okay? So this is the unit rate of dogs. Alright? So if we use this unit rate and compare it to the 80 animals in the shelter, okay? So that we would take the unit rate of dogs, the 0.3125, and we would multiply it to the 80 animals in the shelter. And when you do that, then you get a number that kind of makes sense. That works out to be 25. So there's 25 dogs in this particular animal shelter. Okay? Now then, there's other ways of doing it, and I'm not exactly sure because I didn't go through all the lessons how they taught you. But I decided to show you this since I want to just be kind of consistent with the other problems. Okay? It still works, even though there's no such thing as 0.3125. I mean, we could get gross, but let's not. Okay? So that's just a way of using a unit rate in this particular thing. Okay, I think I'm going to skip that one. That's just using fractional, so obviously all your things are fractional. I'm sure if you can read, you'll get that one right. That one's the same thing. Okay. This one I'm pretty sure you got. I noticed in your quiz that you got this one right. Find the unit rate, 450 push-ups in 18 days. So you're just going to divide 450 by 18 and get your answer. And I think you got that one right on the quiz, so I'm not really going to spend a lot of time on it. And so this is 25 push-ups a day. All right. This one isn't any different from what we've been doing, except for they throw fractions at you. Okay? If we set this up like we've been doing the other ones, okay, it's going to look weird, but just go with the flow. All right? So Rocco assembles 5/6 of a trundle bed in 1/3 of his shift. Okay? So the first thing we want to do is make a ratio of this and this. So if this was a whole number and this was a whole number, we would put whole number over whole number, but they're fractions. But let's just humor me and just do the same thing. So 5/6 of a trundle in 1/3 of a shift. Now that is just some crazy looking math, okay? Alright, so what I want to talk about is something I kind of already did on another piece of paper over here. This is our crazy thing. Is we want to, when we're dealing with fractions, let's write it with the division symbol so that we can get rid of this, all these bars. See, we got a fraction and then a division and another fraction. It's just driving us crazy. It's confusing. So we're going to change this guy to that little division symbol. Okay, so we're going to rewrite this as 5/6 divided by 1/3 because that's exactly what we're doing right here. But this kind of helps our brain calm down a little bit. Now there's a trick that I've taught and I've been taught, and it's pretty, I don't know if you've been taught it, but I'm going to teach it to you really quick. It's called keep, change, flip. When you're dividing fractions, keep, change, flip. What that means is you keep the first fraction the same. Don't do anything with the first fraction. You're going to change the division symbol to multiply, and you're going to flip the second fraction upside down. Keep, change, flip upside down. All right? So we're going to keep the first one, change division to multiplication, and flip this guy upside down. So that's what it looks like. So now we're just multiplying fractions, which is a lot easier on the brain. So we're going to multiply across the top. 5 times 3 is 15. Multiply across the bottom. 6 times 1, 6. And put it back in the fractions. So there's your rate. All right, but the question asked, find the unit rate. Find the unit rate. So all we have to do at this point, you probably already see I've cheated here, is just divide those numbers. So 15 divided by 6, and you get this 2.5. You may not be able to see that. 2.5. That's the unit rate. So what that means is that he can assemble 2.5 beds in one shift. However long his shift is, it doesn't matter. It's in one shift. So that's the unit rate. So even though they threw fractions at you, curveball, as long as you remember, write it out. This just makes more sense for most people. Even when I was teaching college math, a lot of times those kids could see it better if I wrote it out like this when we're dealing with fractions. And remember, keep, change, flip. You should be golden. Okay? All right, so here's another one. Let's see here. The ratio of students failing the test to the students passing the test. Failing, passing. And there was 143 students who took the test. How many did not pass? Okay, this is just like the dog and the cats. All right, so let's put this together. How many out of this right here, how many total took the test out of this right here? So 9 passed, 2 failed, so altogether 11 people took the test. So, and we're looking for failing, did not pass, failing. So 2 kids failed out of 9, 10, 11 kids that took the test. Okay, so that's a rate. All right, change it to a unit rate, so divide. So we're going to get a funky decimal again. Okay, 0.1818. All right, so that's how many failures per test taker. Does that make sense? Fail per test taker. Okay, so right here, if 143 students took the test, and this is your failure rate, you're going to take that number, your unit rate, and multiply it times all the students that took the test. All right, and that comes out to a nice number that makes sense again. So 26 students out of all those guys failed the test. Okay, so that's just like the dog and cat one. Okay. This one, one full day, 108 gallons of water seep into the pond. At this same rate, how many gallons will seep in the pond in 60 hours? So the trick is, hopefully you know how many hours are in one full day, right? 24. So if 108, sorry about that, 108 gallons seeped into the ground or the pond, whatever, in 24 hours. Find the unit rate, divide. So the unit rate is 4.5 gallons per hour. Okay, now we want to see how many gallons seep in there is 60 hours. So we're going to take our 4.5, our unit rate, times 60. And we find out that